everyone. I'm going to be on page 49 of the yellow book, going over the homework. So problem number 1, they gave us 5, 10, 15, blank, 25, 30, and blank. So let's take a look. What's taking place between these numbers? It looks like we're adding 5 each time. So that could be 20. That could be 35. So do we have a common difference or a common ratio? Well, we have a common difference because we're adding or subtracting. So this is a common difference. So circle that. So what is the common difference? The common difference is plus 5. And is it arithmetic or geometric? Well, it's arithmetic because we're adding. That's all we have to do on that problem. Let's go down to number 2, which is on the bottom left of the page. We got 20, 10, blank, 2.5, blank, and then dot, dot, dot means it keeps going. So what are we doing from here to here? It's going to take place. And if you said we're dividing by 2, you're right. Dividing by 2 is the same thing as multiplying by half. So half of 20 is 10, half of 10 is 5, half of 5 is 2.5, half of 2.5 is like 2.5 divided by 2, etc. So you could find that out, which is like 1.25. Do we have a common ratio or a common difference? Yeah, we have a common ratio, so circle that one. Common ratio because we are multiplying by half, and that is our common ratio. Is it arithmetic or geometric? It's geometric because I am multiplying to get to the next term. Number 3, it goes from top right, 2, 5, 8, blank, 14, and blank. So what are we doing for each term? Yeah, it looks like we're adding 3 each time. So this would be 11, this would be 17. Okay. Do we have a common ratio or a common difference? Well, we have a common difference because we're adding. What is our common difference? We're adding 3 to the previous term. Being that we're adding 3, it has to be arithmetic. Just making sure I had those all right. Good. All right, and then number 4 was the last one I asked you to try. We have 3 to 24, blank, to 12, to 6, dot, dot, dot. Okay, so what do you think is taking place from here to here, here to here, here to here? I think we're subtracting 6. So this goes to 18, and 18 minus 6 is 12. Cool, it worked. So do we have a common difference or a common ratio? Well, we're subtracting 6, so I have a common difference. What is my common difference? Well, my common difference is subtract 6. Would this be arithmetic or geometric? It has to be arithmetic. So if you add or subtract to get to the next term, it has to be arithmetic. Next, I'm going to go to the review that you have. So make sure you have that sheet of paper. So the first problem looks like this. Oops, I've kind of miscalculated it. X minus 7 equals 9. So we want to solve this. So we're going to distribute. So 3 times x is 3x. 3 times negative 7 is negative 21. It's equal to 9. So what I want to do to both sides is I want to get x by itself. So I have a minus 21, so I'm going to add 21 to both sides first. Those cancel each other out. That leaves me 3x equals 30. Then, because 3 and x are being multiplied together, I'm going to divide each side by 3. Reduce where you can. 30 over 3 comes out to 10. So there's our answer. The next problem is x over 7 plus 1 is equal to negative 2. Okay, so I want to do a couple things. Remember we cleared the fraction? So if I multiply everything by 7, that should work nicely. That's going to cancel out. 1 times 7 is 7. 7 times negative 2 is negative 14. Now we can go ahead and subtract 7 from both sides. I get x equals negative 21. There's our answer. The next problem is negative 2 2x plus 5 equals 8. We're going to distribute the 2 over the parentheses, so I get negative 2x minus 10 equals 8. Why don't I distribute the negative 2 to the 8? It wasn't in the parentheses. So now we're going to go ahead and make that our equal sign. We're going to add 10 to both sides. Those cancel out. Divide each side by negative 2. Those cancel. So our answer is going to be negative. 18 divided by 2 is 9. So x equals negative 9. Next problem, I have 5x minus 9 is equal to 6. I can just start adding stuff. So it's a negative 9, so I'm going to add 9 to both sides. Those cancel. 5x equals 15. Divide both sides by 5. Those can't reduce. Reduce 15 over 5, which comes out to 3. Okay, so the problem below, they have two equations. You have f at n equals 2n plus 5. And you also have g at n equals negative 4n minus 2. So the very top row, we say we want f of 5. Well, that's going to be 2 times 5 plus 5, which is 10 plus 5, which is 15. We have f at negative 2. So I'm going to plug negative 2 in. So I get 2 times negative 2 plus 5. 2 times negative 2 is negative 4 plus 5. Gives me an answer of 1. And then notice it now changes a little bit different. I'm not plugging that 11 in. I'm setting 11 equal to that and solving it. So I get 11 equals 2n plus 5. And let's go ahead and solve it, just like we've been doing. I'm going to subtract 5 from both sides. 11 minus 5 is 6 equals 2n. Divide each side by 2. So n equals 3 because 6 over 2 is 3. And then our last one we have f at n equals negative 3. This is done the same way. So we're going to get negative 3 equals 2n plus 5. Let's go ahead and solve it. I'm going to subtract 5 from both sides. Those cancel, so I get negative 8 equals 2n. Divide both sides by 2. So n equals negative 4. If you have any questions about this, you can ask me or ask your teacher. So the next problems that are on the page, I'm going to switch page. Notice I have the g at n that I'm going to use. So the first one, I want g at 8, which is going to be negative 4 times 8 minus 2. That's negative 32 because negative 4 times 8 is negative 32. Goes more negative, so I get negative 34. I want g at negative 3, which is negative 4 times negative 3 minus 2. Again, I'm replacing the n. Negative 4 times negative 3 is positive 12. Minus 2, I get an answer of 10. And then these last ones, g at n is equal to negative 6. So I'm going to take negative 6 and set it equal to our equation. Go ahead and solve it. Oops, wrong place for that. Straight down that way. All right, so I'm going to add 2 to both sides. Negative 6 plus 2 is negative 4. Divide both sides by negative 4. Negative over negative is positive, so n equals 1. And I have g at n is equal to 0. So take the top equation, set it equal to 0, and solve it. Go ahead and add 2 to both sides. 2 equals negative 4n. Divide both sides by negative 4. Reduce the fraction, so I get negative 1/2. Because 2 goes in itself once, 2 goes in 4 twice. Number 3. They want us to find the common difference. We'll call it CD. So we have 5, 11, 17, 23, 29. What am I doing to each number? And so what am I doing for each, what do I do to get to each set of numbers? Looks like I add 6. So that means my common difference is 6. Problem number 4 goes from 1600 to 400 to the 100 to 25. And they want to know what the common ratio would be. Call it CR. So what am I doing for each of those numbers? How am I getting from one to the next? Yeah, it looks like I'm dividing by 4, or you could say I'm multiplying by 1/4. That's the same thing. So our common ratio is multiplying by 1/4. For problem number 5, we have our grid given. We have n, f at n. And then we have 0, 1, 2, 3, 4, 5. We have -7, 3, 13, 23. And then we want to fill in the rest. First thing we have to determine, what am I doing to get to each number? Am I adding, subtracting, multiplying, or dividing? We are adding 10. So if I add 10 to 23, I get 33. If I add 10 to 33, I get to 43. So make sure you fill in those blanks. Being that we're adding, is it arithmetic or geometric? It is arithmetic. So circle arithmetic, okay? And then what is our, because it's arithmetic, we're going to have a common difference. So what is the common difference? Well, the common difference is plus 10. And then we want to say, what is our recursive function? It's basically previous plus 10. Our explicit, so a couple things we need to take note. This started at 0, -7. Agree? So I'm going to do f at n. I have my common ratio. So I'm going to go 10n. And because it started with 0, that's going to be -7. This equation works all the way through. If I take 0, plug it in, I get -7. If I plug 1 in, 10 times 1 is 10, -7, 3. If I plug 2 in, I get 20 -7, which is 13, so on and so forth. Okay, so please, please, please note that 0 being there means something. Okay, if that's the case, that's everything plugs in very simple to our problem. Okay, flip over your paper, go to the back side. This is number 6. We have n, we have f at n. We have 0, 1, 2, 3, 4. We have 10, 4, 1.6, blank, 0.256. Okay. Well, we're not subtracting. I think we are dividing. What do we do? How are we dividing? I think we're dividing by 4. If I divide by 4, that's the same thing as multiplying by 1/4. So let's see. If I go 1.6 times 1/4, that becomes 1.6. Let's see, that's going to give me, what does that come out to? You might want to have your calculator out. And 1.6 divided by 4, that gives us 0.4. Okay, is that a common ratio? Or is this arithmetic or geometric? Well, because I'm multiplying by 1/4 or I'm dividing by 4, that means it has to be geometric. If you multiply or divide to get to the next term, it's geometric. What's our recursive function? It's going to be previous or next, something like that, times 1/4. Our explicit function means one of two things. Did I start, is that a 0 here? And the answer is yes. This is my first term. This is my ratio. So you're going to do f at n. First term is 10. Common ratio is 1/4. I'm going to raise my common ratio to the n power. Because this 0 is here, if I plug go 1/4 to the 0, that becomes 1. 1 times 10 is 10. That worked. If I plug 1 in, it's going to work as well. I think I did that right. Cool. Because again, that started with 0. I don't think the ones on the test will be quite as tough, but just take a look at them. Number 7, I have n and f at n. And I get 1, this is 1/4. 2, this is 1/8. 3, this is 1/16. 4, we don't know. 5, we don't know. what does it appear that's taking place? Am I adding, subtracting, multiplying, or dividing? Well, take a look at the denominators. How would I go from 4 to 8 to 16? Yeah, you'd multiply by 2. So in this case, because it's a fraction, I'm going to multiply by half. So half of 1 over 16 is 1 over 32. Just double the denominator. Half of 1 over 32 is 1 over 64. So the fifth term is 1 over 64. Okay, I'm multiplying, so this has to be geometric. What is our common ratio? Our common ratio is times 1/2. Okay, so common ratio. It's common ratio because it's geometric. So my recursive is going to be, next or something like that, next times half. So you just give some lingo of that you know what it's going to give. My explicit, I'll do it right here because I have a little bit more room. Okay, a couple things. So let's do this. F at n equals 1/4 times 1/2 raised to the n. I'm actually going to move this over a little bit because I'm going to run out of space. Okay, so something I want you to notice. Does this start with 0? The answer is no. If I plug 1 in, I get 1/2 to the first, which is 1/2. 1/2 times 1/4 is 1/8. So notice this is kind of doing the diagonal. So we have to think about shifting it. So what I'm going to do is, because this started with a 1, this is going to be an n minus 1. This is our equation. So be aware of that. You can make a mental note. If it doesn't start with 0, it starts with 1, you're going to change that exponent a little bit. All right, let's go to number 8. Last question. So we have n, f at n. I got 1, 2, 3, 4, 5. I got -7, -10, -13. What does it appear that's taking place? How do I get to the next term? It looks like I'm subtracting 3. Do you agree with that? So -13 minus 3 is going to give me -16. Minus 3 again, -19. So is this arithmetic or geometric? It is arithmetic because I have a common difference. I'm subtracting. If I add or subtract to get to the next term, it has to be arithmetic. So this has something called a common ratio, or common difference, excuse me. And the common difference is -3, so fill that in your blanks. Our recursive function is going to be something like next minus 3, something like that, or previous -3, something like that. And then my explicit function, I might be able to do this. So we're taking a look at that. We're going to go f at n equals -3n minus 7. Okay. If I take 1 and I plug it in right here, that is going to give me -3 times 1 is -3. -3 minus 7 is -10. Okay, remember on the last one, this is actually doing the diagonal again. Okay, remember we went n minus 1, so let's take this down a little bit. Okay, so this, we have to modify that. So f at n, -3, parentheses, n minus 1 minus 7. That's your answer. Okay, why is it n minus 1? Because I started with the very first term being a 1, not a 0. Now, some of you might want to distribute this, or some of you might have seen the pattern that if we went backwards. So this becomes -3n plus 3 minus 7. And those are like terms. So I get -3n minus 4. So what answer would I accept? Well, I would accept this answer, but I would also accept this answer. Now, I just want to make clear why I would accept that bottom answer. If you realize if I went backwards this way and I made this as 0, I'm subtracting 3. So if I add 3, I get to -4. And if I use that, thank you. If I use the 0, 4, I would go, I'm still going to do f at n equals -3 n minus 4. Okay, so the minus 4 goes at the back. Common difference there. Negative 3n minus 4. Is that the same as this one down here? It sure is. So make sure you watch and rewatch this video. Make sure you have it down, and we do have a test next time we have class. Have a nice day. Take care of one another.